Hello, this is Timothy with Growling Pigeon Studio, and as you can see, I have rearranged the computer room a little bit. Not exactly what I would like to do ultimately, but hey, the lighting is a little bit better. I don't look nearly as orange. I think we're on the right track. So today I want to continue our discussion on unit tests, and specifically I want to touch on a cool little feature, I guess you could call it a feature, of unit tests. And that is using unit tests to define how something that you're pulling in works. So say, for example, that you're pulling in an open source project that you're going to use as a dependency, and it has some weird ways of being used, and so you can use unit tests to say, hey, this is how it's supposed to be used, this is how it works, use it this way, this is the expected behavior, and so on. It helps to protect against these open source projects or NuGet packages or products that your company owns or something that you yourself are writing or whatever. It helps protect against any problems that might arise as they're updating it. They'll fix a bug and think everything's great, but one little thing didn't get through, or maybe they intended to change behavior. And so you pull in the new NuGet package, or you download the new assembly or DLL or whatever, and you run the unit tests, and one or two or 50 of them break, and you can say, okay, well, yeah, obviously the behavior has changed, so what we need to do is X, Y, and Z, right? Or maybe just revert back because you don't care about the security issues, or maybe there are no security issues because of whatever reason. Cool, so for example, today I'm going to use Datetime. I know that datetime is something that most people who use C# know about, but really basic. I'm just going to illustrate a couple of points. So, for example, how do we get today's date from datetime? Again, just pretend with me that this is something that we've pulled in as a NuGet package, and it's a really, we don't know how to use it yet. It's really foreign to us or whatever. So we can create a new class or a new method, public void. We want to figure out how to get today. So get today. And here we can just define var today equals date time, and then you're reading the documentation or whatever, and you decide, you know what, the way that we're going to figure out today is we're going to use now. That might seem a little bit odd. Why would you use now instead of today? You know, now has a time component, but you've decided in your team that you want it to be equal. You know, you want it to have a time component. And so you might assert that. You might even say assert today, assert is true, and today dot hours or hour is greater than 0. Or even better than that, you can say today dot time of day dot ticks is greater than 0, as an example, to ensure that we have some time component to it, and that whenever we get today from .now, it's always going to have that time component. Now, say that, you know, Microsoft decides to change things, and they decided that, you know what, we're going to deprecate day, and we're going to make now the new day, and we're going to make real now the new preferred way to get a date time with a time component. You can change how your methods work. This works really well when you couple it with your own interfaces. So if you take something that another team has put together, or a NuGet package, and it works really in a weird way, it doesn't jive with the rest of the way that you program. Maybe they use lowercase methods. I don't know. There's plenty of examples. We can create an interface that wraps around what we want to capture. So for example, I could And you would do this in other files, of course. But let's say that we want an internal interface time, and you want to get date time, and we'll call it today, or even better yet, we'll call it get today. There's your interface. So you don't want to do date time now, you want to go through time and get today, right? And internal class time, and we extend time public date time get today, if I can spell, right? And you know, we don't even need a body, we can just do date time now. Fantastic. And then you can say, all right, we no longer want to deal with date time, but we're going to maintain this test right here to ensure that this always works the way that we expect it to, and if it changes, then we know that whenever we pull in this interface of time, through dependency injection or any other compositing pattern where it brings in time, we know that it will change this behavior. So we can have get today, and we can say also var my today equals time dot get today, and of course that's not static, so new time. Alright, so we get my today. We can assert, of course, as well. Assert is true my today time of day equals my today time of day. Now this may not always come out true. You want to find some other way to ensure that this always works the same way. However you do that, it's just an example. Of course, with date time, things are going to change. You could have another tick in the middle of the execution of this unit test, and so you'll get false negatives. You could also get false positives for whatever reason. Bad code, necessarily, but the example, I think, should get through. Anyway, if you took the time to listen to this really crappy presentation, then good on you. Thank you very much. It's been a long couple of weeks. We've had a lot going on, and I really need to get a video out. So thank you for taking the time to listen to me jabber. Also, if you're interested at all in going through a couple of videos about design patterns, that's something that I think would be a lot of fun as well. But let me know what your interest is. Otherwise, I'll just cover the couple of design patterns that I like to use and leave all the rest of them by the wayside and have a whole bunch of comments later on of why didn't you cover the rest of them, you know, that sort of thing. Anyway, thank you for watching. You have a good one. Bye.